February 1943. Sidi Bouzid, Tunisia. Through his binoculars, a veteran commander of the German 21st Panzer Division watches an advancing line of American M3 and M4 tanks. These are untested crews in their first major campaign. When the first German shells land, this inexperienced armor is expected to fracture into disorganized, isolated duels. But the Americans do not scatter. They execute an immediate, synchronized repositioning, reacting to the barrage as a single organism. They are communicating with a speed and clarity that startles the battle-hardened Germans. How did a nation that barely possessed a tank force 3 years prior suddenly challenge the pioneers of armored radio warfare? The historical reality is undisputed. The German military had revolutionized modern warfare by placing a standard transceiver, the FUG-5, in nearly every tank. This invisible tether gave them the decisive communication edge to crush Poland, overwhelm France, and dominate the early Desert War. Yet the sudden tactical synchronization that startled the Afrika Korps reveals a profound technological shift. This is the forensic breakdown of how the United States, starting from absolute zero in armored doctrine in 1939, frantically manufactured and mastered a standardized, division-wide communication network. Stripping away post-war triumphalist myths, the investigation focuses on the actual hardware, the brutal logistical learning curve, and the intense human friction behind America's desperate industrial gamble against battle-tested German doctrine. To understand how this communication net arrived in the Tunisian desert, the timeline must first trace back to the critical vulnerability paralyzing the U.S. Army when Europe erupted in flames. The year is 1939, as the Wehrmacht's Panzer Division sliced through Poland, demonstrating the devastating potential of coordinated, radio-directed armor. The United States Army possesses a grand total of exactly 327 tanks. Most are obsolete. More critically, the method used to command them belongs to a bygone era. If an American tank commander in 1939 wanted to order a platoon maneuver, he did not reach for a microphone. He opened his hatch, stood exposed to potential enemy fire, and waved brightly colored signal flags. In poor visibility or thick dust, he relied on hand gestures, or he blasted a mechanical siren. In an era where milliseconds of reaction time dictated armored survival, the American Tank Corps was effectively deaf and mute. Across the Atlantic, German doctrine had already embraced the electromagnetic spectrum as a primary weapon of war. By the time Erwin Rommel's forces began pushing across the North African desert in early 1941, German tanks were standardized around the Bordfunkgerät systems, primarily the FUG-5 transceiver. These operated on amplitude modulation, or AM, while AM radio was susceptible to static interference from engine spark plugs, atmospheric conditions, and the metallic clatter of the tank itself. The German military had refined its application through rigorous peacetime exercises and actual combat experience in Europe. Their crews spoke a practiced, standardized, tactical language. They fought as networked units. Recognizing this catastrophic gap, the U.S. Army Signal Corps realized that simply copying German AM technology would not be enough. They needed to leapfrog it. They made an unprecedented, high-stakes gamble. Instead of adopting proven AM technology, the Signal Corps chose to rely on frequency modulation, or FM. FM was a nascent technology, largely untested in military applications, but it offered two distinct theoretical advantages: a massive reduction in static interference and clear, high-fidelity voice transmission even over the deafening roar of a radial tank engine. The result was the development of the SCR-508 and SCR-528 radio sets. These were heavy, complex, multi-channel transceivers featuring push-button frequency tuning, a radical departure from the delicate manual dials of earlier sets. But designing a revolutionary radio in a New Jersey laboratory was entirely different from fielding it across an army of millions. The decision to mass-produce the SCR series triggered an immediate industrial crisis. These sets required precise frequency control, which meant the military suddenly needed millions of perfectly cut quartz crystals. Before 1940, the U.S. crystal industry was a niche artisanal market, producing maybe 100,000 units a year. Now, the War Department demanded millions. Furthermore, these radios relied on fragile glass vacuum tubes. Engineers had to figure out how to manufacture millions of these delicate glass components so securely that they could survive the bone-jarring, violent mechanical vibration of a 30-ton Sherman tank moving off-road, as well as the searing heat of a desert environment. The technological bottleneck was matched only by the human friction of rapid mobilization. The U.S. Army was expanding at an explosive, almost unmanageable rate. The men drafted to crew these new tanks and operate these advanced radios were not career soldiers or communications engineers. They were farmers from Iowa, mechanics from Detroit, and clerks from New York. In a matter of months, training commands had to transform tens of thousands of civilian draftees into proficient radio operators. They had to teach men who had never seen a two-way radio how to calibrate complex FM circuitry, diagnose vacuum tube failures in the dark, and, most importantly, communicate using a rigid, standardized tactical brevity code. The chaotic improvisational slang of civilian life had to be entirely erased and replaced with a uniform operational language. Every delay in manufacturing, every failed crystal shipment, and every botched training exercise consumed time that the Allies simply did not have. The clock was ticking toward an inevitable collision with the world's most experienced armored force. The Signal Corps and the Armored Force were attempting to compress a decade of doctrinal evolution and technological refinement into barely 24 months of frantic wartime mobilization, sending thousands of men into combat relying on an untested electronic lifeline. When these newly equipped American armored divisions finally rolled onto the African sands in late 1942, the theoretical hardware and the men desperately trained to use it were put to their first brutal practical test under enemy fire. The theory met reality in the jagged, dusty passes of Tunisia. When the first armor-piercing shells slammed into the advancing American formations, the visceral terror of actual combat threatened to instantly shatter unit cohesion. In previous wars, an ambushed commander would have desperately scanned through narrow vision slits, searching the dust for a colored flag from a platoon leader. Now, sealed inside the steel hull of an M3 Lee or an M4 Sherman, a panicked 20-year-old tank commander did not need to blindly hunt for a visual signal. He did not even need to carefully turn a delicate tuning dial while high-explosive fire rocked his 30-ton machine. He simply slammed a heavy mechanical push button on his radio set. Because the channels of the SCR series were crystal-controlled and meticulously preset before the battle, that single physical motion instantly broadcast his voice across his entire platoon. Under the terrifying stress of German anti-tank ambushes, Green crews bypassed the fine-tuning process entirely. They shouted warnings, coordinated coordinates, and called out flanking movements in real time. A few miles away, inside the cramped monitoring vans of the German Funkhorstdienst, their radio intelligence listening units, officers braced for the familiar disciplined traffic of a few command vehicles. Instead, their headsets suddenly erupted with a chaotic, localized wall of sound. The German operators quickly realized they were not just intercepting a handful of specialized platoon leaders. They were overwhelmed by an unprecedented volume of synchronized voice traffic. The Americans had rolled out of the factory with every single tank functioning as an active independent broadcasting station. This saturation of vehicle-to-vehicle chatter initially shocked the German listeners. Yet the friction of this new reality was severe. Terrified American draftees frequently broke protocol under fire, crowding the airwaves with panic shouting as they faced veteran German gunners. But having a radio bolted into every turret and transmitting with push-button speed was only the first layer of the communication puzzle. The true complexity lay in how this massive network was wired across the battlefield and how the enemy adapted to listening to it. The overwhelming wall of sound intercepted by the Germans in those opening engagements was not random noise. It was the byproduct of a radical new battlefield architecture. To understand how the Americans achieved this startling synchronization, one must look inside the turret of an M4 Sherman command tank, where the heavy steel-cased SCR-508 radio set was bolted securely to the sponson. The brilliance of the American system lay not just in its transmission quality, but in its overlapping network design. The SCR-508 was not a simple two-way radio. It was a complex unit containing one transmitter and two independent receivers. This dual receiver configuration allowed for a continuous, unbroken chain of command that required absolutely no manual rewiring or frantic dial turning under fire. The architecture worked like an electronic nervous system. A platoon leader's first receiver was permanently locked onto a specific frequency, say Channel A, which connected him exclusively to the 5 tanks in his immediate unit. Simultaneously, his second receiver was locked onto Channel B, the wider company command net. If a scout tank on the front line spotted a concealed German anti-tank gun, the crew instantly broadcast the coordinates on Channel A. The platoon leader heard the warning in his headset, immediately depressed the heavy mechanical push button for Channel B, and relayed the target to his company commander. That company commander, in turn, possessed his own dual receiver set, monitoring Channel B while simultaneously linked to Channel C, the battalion net, which tied directly into supporting artillery batteries and reconnaissance squadrons. Within a matter of seconds, critical targeting data could pass from a single frontline tank all the way to a heavy artillery emplacement miles away, fluidly jumping across discrete frequency tiers without a single crew member having to take their eyes off the battlefield to tune a dial. But the true genius of the American network was not just the overlapping channels. It was the fundamental physics of the transmission itself. The North African desert was a notoriously hostile electronic environment. The relentless Sirocco winds carried highly charged sand particles, creating severe electrostatic discharge that continuously built up on the metallic hulls of the armored vehicles. Furthermore, the massive radial engines powering the tanks generated intense electrical interference. For the British and German armored units relying on traditional amplitude modulation, or AM radios, this environment was a nightmare. AM signals carry sound by altering the amplitude, the height of the radio wave. Unfortunately, static electricity and engine interference also manifest as spikes in amplitude. For a German panzer commander listening through a standard AM receiver, every spark plug misfire, every lightning strike in a distant thunderstorm, and every discharge of static from the sand translated into a deafening, crackling roar in his headset. Prolonged combat operations frequently left crews with severe headaches, struggling to decipher distorted robotic voices through an ocean of electronic noise. The American Signal Corps bypassed this problem entirely by utilizing frequency modulation. FM technology carries sound by rapidly altering the frequency of the wave, while the receiver's circuitry actively clips off any spikes in amplitude. Because the static lived in the amplitude peaks, the FM receiver simply discarded the noise. The tactical result of this physical difference was staggering. When an American tank commander pressed his microphone switch, he did not project a distorted buzz. He projected high-fidelity voice transmission. The audio clarity was so precise that crews could instantly recognize the specific timbre of a platoon leader's voice over the deafening mechanical roar of the tank interior. They could hear the subtle inflections of calm or panic in a man's breath. In the chaotic, terrifying sensory deprivation of armored combat, where visibility was often reduced to a few yards of swirling dust, this crystal-clear voice fidelity was an unparalleled psychological and tactical lifeline. This abrupt shift in electromagnetic physics created an immediate, unforeseen crisis for the German military. The Wehrmacht's radio interception service, the elite Funkhorchdienst, was arguably the most experienced signals intelligence organization in the world. For years, they had masterfully monitored, triangulated, and decoded British and French AM traffic. Their standard interception equipment, including the highly refined Torn.E.B receivers, were masterclasses of engineering, but they were fundamentally optimized for standard European AM military bands. The new American FM radios operated on a very high frequency, or VHF band, specifically between 20 and 27.9 MHz for the armored units. VHF radio waves behave very differently than lower frequency signals. They do not bounce off the Earth's ionosphere to travel over the horizon. They propagate strictly by line of sight. If a solid mass, like a large hill or a ridgeline, stood between the transmitter and the receiver, the signal was effectively blocked. Consequently, the highly sophisticated German listening posts, which were traditionally situated in secure locations miles behind the front lines to monitor long-range AM chatter, suddenly found themselves staring at blank logs. The Americans were maneuvering through the treacherous wadis and valleys of Tunisia, coordinating complex, multi-battalion movements in what appeared to the German rear echelon interceptors as complete electronic silence. For a brief, agonizing window, the Afrika Korps intelligence officers, men who were accustomed to predicting Allied armor movements hours in advance by analyzing radio traffic volume, found themselves completely tactically blind to the local maneuvers of the American tank columns. However, the German military apparatus was notoriously adaptive, and this veil of electronic secrecy did not last long. The breakthrough for the enemy came not from their intelligence officers, but from their frontline infantry. During the brutal, chaotic skirmishes in the central Tunisian passes, German anti-tank gunners managed to disable and capture several intact American M4 Shermans. These prized captures were immediately swarmed by German technical intelligence teams. When the signals engineers unbolted the heavy steel-cased SCR radios from the sponsons and pulled them apart on field workbenches, they were genuinely stunned by what they found. They examined the complex arrays of fragile glass vacuum tubes, marveling at the heavy, intricate shock-mounting systems specifically designed to absorb the violent, bone-jarring impact of cross-country travel. They analyzed the banks of precisely cut quartz crystals that locked the frequencies perfectly in place, eliminating the need for delicate manual tuning. Veteran Afrika Korps commanders, reviewing the technical autopsies of the captured gear, were forced to make a sobering admission. Official reports filed back to High Command bluntly acknowledged the profound engineering superiority of the American hardware. The analysis confirmed the Germans' worst fears. The Americans possessed the technological capability for total internal connectivity. An American armored column was not merely a collection of individual steel boxes operating in the same physical space. It was a synchronized hive. If this high-fidelity network remained unbroken, the standard German tactical doctrine of drawing enemy tanks into isolated traps and destroying them piecemeal would become drastically more difficult, if not impossible. The American hardware represented an existential threat to German armored supremacy. Yet just as the German engineers were documenting the brilliance of the American machinery, the frontline German intelligence officers discovered the network's fatal flaw. The radios were mathematically and physically perfect. The men operating them were not. Recognizing the strict line-of-sight limitations of the American VHF bands, the Funkkurzdienst rapidly adjusted their tactics. They pushed modified receivers and mobile listening posts out of the secure rear areas and moved them dangerously close to the front lines, positioning their antennas on high ground to catch the horizontal signals. When the German intercept operators finally locked onto the exact frequencies dictated by the captured American quartz crystals, the linguists could barely believe what they were hearing. The pristine, high-fidelity FM transmission that the American engineers had labored so desperately to perfect was indeed delivering American voices with absolute, uncorrupted clarity. And those voices were broadcasting sheer tactical suicide. The tens of thousands of green American draftees, thrust into the visceral terror of high-explosive combat for the very first time, completely abandoned their rushed Signal Corps training. Under the extreme psychological pressure of German artillery barrages and concealed anti-tank fire, strict radio discipline evaporated. Instead of relying on rigid, encrypted brevity codes and designated call signs, the terrified tank commanders spoke in the clear. They reverted to the colloquial improvisational slang of civilian life. They called out to their platoon mates by their first names. More disastrously, they broadcast their exact grid coordinates, their ammunition shortages, their casualties, and their immediate tactical intentions over the open airwaves. Through the pristine clarity of the FM signal, German intelligence officers heard exactly what the American company commanders heard. They listened to desperate warnings about concealed anti-tank guns. They heard exhausted platoon leaders explicitly state which ridgeline they were retreating behind to refuel. They heard the exact moment an American flank collapsed in panic. In their desperate attempt to survive the chaos of their first campaign, the inexperienced American crews were inadvertently narrating the entire battlefield in real time. The brilliant technological advantage of the FM network was instantly and lethally inverted. The German intelligence officers sitting in the cramped, sweltering interiors of command half-tracks just a few miles away did not need sophisticated cipher machines or teams of elite cryptanalysts to break the American codes. The Americans were simply handing them the tactical map, complete with troop intentions and logistical vulnerabilities over the open ether. By listening directly to the unencrypted panic of the tank commanders, veteran German officers could anticipate the American maneuvers before they even happened. They could identify exactly which units were out of armor-piercing ammunition and calmly reposition their devastating 88mm guns to intercept the retreating columns. This dangerous gap between advanced hardware and catastrophic human radio discipline transformed an impenetrable communication network into a lethal liability, setting the stage for a catastrophic collapse when the American armored network finally faced the full, concentrated fury of Rommel's imminent counteroffensive. In mid-February 1943, that catastrophic collapse materialized at the Kasserine Pass. When Erwin Rommel's veteran panzer divisions smashed into the American lines, the resulting slaughter shattered a fundamental illusion of modern warfare: the belief that superior technology alone can manufacture a victory. Inside the American Shermans and Lees, the SCR radios functioned flawlessly, delivering high-fidelity FM signals exactly as the engineers in New Jersey had promised. But the brilliant mechanical network was paralyzed by a total failure of high-level command. American generals had deployed their armor, infantry, and artillery not as a unified fist, but as isolated piecemeal fragments scattered across the valleys. There was no coordinated tactical plan to tie the overlapping radio networks together. As German armor severed these disconnected defensive pockets, the state-of-the-art communication system became an instrument of psychological terror. The crystal-clear channels did not organize a defense. They merely accelerated the transmission of chaos across the entire front. Frontline tank commanders, begging for artillery support, were instead met with contradictory orders from panicked senior officers operating miles to the rear. Because the dual receiver architecture linked the echelons so tightly, inexperienced crews were forced to listen in real time as neighboring platoons were surrounded, outgunned, and systematically dismantled by advancing German panzers. The pristine audio fidelity only made the sounds of burning tanks and dying men more intimately horrifying. Kasserine Pass laid bare an agonizing reality. An invisible, high-tech web of communication is completely useless and actively destructive when the operational leadership behind the microphones collapses under pressure. It was a bloody, humiliating disaster that cost thousands of casualties, but it forced an immediate, radical overhaul of how American commanders wielded their electronic arsenal before the final showdown in Tunisia. That overhaul arrived in early March 1943 with the appointment of Lieutenant General George S. Patton taking command of the shattered Second Corps. Patton instituted a ruthless regime of discipline that extended directly into the electronic ether. The panicked, open-air chatter that had fed German intelligence at Kasserine was eradicated. Strict brevity codes were enforced under threat of severe punishment. Tank crews were ordered to maintain absolute radio silence until combat commenced. The hardware remained the same, but the men operating it were forced to match its precision. The ultimate test of this brutal reorganization came on March 23rd at the Battle of El Guettar. Sweeping down a broad desert valley, the veteran German 10th Panzer Division launched a massive armored thrust. German commanders anticipated a repeat of Kasserine. Their intelligence officers monitored the VHF bands, expecting to intercept terrified Americans narrating their own collapse, while the panzers prepared to carve through disjointed defensive pockets. Instead, they drove into a synchronized killing zone. When the German vanguard rolled into range, the American airwaves did not erupt in panic. The overlapping FM networks functioned with lethal efficiency. Frontline American tank destroyers and Sherman crews instantly broadcast exact grid coordinates using rigid tactical codes. Platoon leaders seamlessly kicked the targeting data up to the company net without a single crew member breaking visual contact with the enemy. The dual receiver architecture bridged the gap between forward armor and rear echelon fire bases. Within minutes, a devastating barrage of heavy artillery shattered the German formations, orchestrated entirely over the airwaves. When surviving panzers attempted to press the attack, they found American tank companies executing highly coordinated tactical retrogrades. Using their push-button transceivers, U.S. commanders synchronized complex fighting withdrawals and rapid flanking maneuvers in real time. They repositioned as a unified, reactive organism rather than scattering into individual duels. The momentum of the 10th Panzer Division was systematically broken. The shattering of this German thrust at El Guettar marked a permanent shift in desert warfare, carrying profound implications for how the remainder of the Second World War would be fought. For the veteran German commanders observing these synchronized fighting withdrawals through their binoculars, the realization was chilling. The Wehrmacht had pioneered the concept of the radio-integrated tank force to execute lightning warfare, building their early doctrine around elite crews and highly specialized equipment. But the United States had taken that revolutionary concept, industrialized it, and effectively democratized it for a rapidly expanding conscript army. America's true triumph in the North African campaign was not fielding an invulnerable tank. An M4 Sherman could be pierced by a German 88mm shell just as easily as any other Allied machine. The fundamental triumph was the creation of a fail-safe, standardized communication network. If a tank was destroyed, a mass-produced replacement Sherman would simply roll off a transport ship, and a hastily trained replacement crew could immediately plug themselves right back into a division-wide nervous system with the single push of a mechanical button. The Tunisian campaign proved definitively that modern mechanized warfare was no longer decided solely by the thickness of a steel plate or the caliber of a main gun. It was now governed by industrial-scale connectivity, absolute logistical standardization, and the ruthless ability of an army to absorb catastrophic failures and rewrite its tactical doctrines in real time. This rapid evolution from a paralyzed, deaf tank corps into a highly synchronized network in the harsh desert terrain left one final, enduring lesson about the nature of American military power in the Second World War. Ultimately, the greatest weapon the Americans brought to the desert was not made of physical steel, but of invisible frequency waves. This robust electromagnetic network bound thousands of individual machines into a single, resilient combat organism. It provided the crucial lifeline that allowed a green, untested army to survive its own disastrous early mistakes, learn rapidly under relentless fire, and ultimately outmaneuver the very masters of the Blitzkrieg who had invented modern armored warfare.